Excellent. 10 hours of Okay, so you've got quizzes back, kind of in the swing of things now. Know what kind of stuff is going on. This week, what's due? You got a project due, yeah? Thursday, yes. Have at it, work together. I just talked to Kelly Smith at the Testing and Tutoring Center down there. There's a couple stat tutors. Some of you may have met them already. They're great. Greg, Jose, Amber, I think, is down there this term. I told her, in the past, I've told the tutors not to help with certain assessments. Like, don't help them with the exams, or don't help with the projects. And the reason I did that was not because I'm a bastard, like I can be. I try not to be, though. The reason I did that was because people, when I started making stuff out of class, like the first out-of-class exam was like two and a half years ago now. I gave an out-of-class exam, just like yours, coming up in a couple weeks. And there was a bum rush on the tutors the night before it was due. And it was posted like 2 weeks early. But people waited, give them enough rope. And they ran down to the tutoring center and just hammered the tutors. And I got this call from Kelly saying, "What the hell's going on?" I'm like, "I don't know," and I got pissed. And I made this edict that says, "No one will use the tutors for exams." And I hate doing that because it felt like I'm punishing you guys for something this class did 2 years ago. So, use the tutors wisely, okay? What's a wise use of a tutor? Of a math tutor, or any tutor for that matter? Nick, go!
Asking them for help when you don't know how to do a question.
Good! What have you done before that, though?
Tried.
Give it a shot. That way you can explain to them
What the problem is.
what you tried, what you don't get. Exactly. Like, I tried this. I know in class he did something with an X and an F column. And they're like, "Oh, yes. What is and they're going to ask you questions like I do. And what is that F column? And what is that X column? They're going to ask you these questions because their job is not to give you answers. Their job is to help you find answers. Good. What's another good use of a tutor? I saw a bunch of hands. Pat.
Work in advance.
Oh, hell yeah. You got to. Do not, if you show up there with a blank paper, they will ask you to, well, they won't ask you to leave. They'll walk away from you. Don't get pissed at them. That's their job. Their job is not to have you hand them a blank piece of paper and say, "Do this for me." Their job is to do exactly what you guys just said. You worked in advance, you explained where you've gotten stuck, and they help you get through that stuck point. Absolutely, and they're fantastic at that. But it can seem like they're being jerks when you're not getting the answer that you want. Suppose you're in a hurry, things like that. That's not the best time to go to a tutor when you're in a hurry. Because they're going to, annoying laugh from the back of the room. Or from the front of the room. Yeah, because they're going to draw it out of you. So what do you think? What do you mean by that? I don't know what I mean by that. Well, they're going to make you know what you mean by that as you go through. So, good use of tutors. Anybody else? Wisdom from experience. These are great ideas.
Don't wait till the last minute.
Please, please. I give you, speaking of which, I was going to say, I give you guys plenty of time on assessments. I tried last night to upload your first exam, which is not due for 2 weeks. I think it's over 2 weeks. I think it's due like the Thursday of week 5, I think. It might be Tuesday of week 5, I'm not sure. It's week 5, regardless. It's all done, ready to go, and then I was sitting at home working remotely, and I realized the program I need, they won't allow remotely. I guess there's some kind of security issue, because punk rock rule, has to do everything his own way. So the program I need, the FTP uploader, didn't work. I will get it uploaded, I'm thinking between 12 and 1 today. It's going to have an Excel spreadsheet that goes along with it. It's a PDF document, an Excel spreadsheet, and a couple images. All those are linked. They're going to be linked either within the document or in the schedule page. I'll send another mass email /love note out to you guys when I get everything uploaded and ready to go. I know I sent you like 5 over the weekend. I apologize for bombing your inboxes. But that's the best way to communicate with you guys. So I'll let you know as soon as they're uploaded. I'll give you the heads up, and you can go to the schedule page and download them and start looking at them. Not everything will make sense today, but by the end of this week, beginning of next, it'll all make sense. Then you'll have plenty of time to get that thing turned in for week 5. Cool? Make sense? Anything you guys can think of right now? Questions-wise. Please, Rick.
Last week, the F in X of F stand for frequency?
Frequency, yes. F is frequency. X is going to be data. Anytime at all, we talk about an X value in this class, it's going to be data, and usually a string of them. If you just see X with no other values, no X sub 1s, X sub 2s, that just means we're dealing with a bunch of data points. And how many data points? Oh, excuse me. Let me ask you a better question. What variable do we assign for how many data points that we have? Do you remember that the value X and F were brought up? If you add up all those F's,
Big sigma.
Remember the letter, big sigma F means add them all up. If you add up all the F's, remember what that little variable we used to talk about the sample sizes? Little n, remember him? Certain variables you're going to be seeing over and over again in this class. We'll see this one again today. If this is like, oh, we're talking about, we'll come back to this, I promise, I promise. So frequency, yes, is F's. That's how often something occurs. For your quiz this week, which is due, I think, on Thursday as well, you have, I think it's Yellowstone?
Yeah.
I think it's the geyser data, great little eruption on geyser data. And you'll have this column to deal with because the data has been given to you in a distribution, so you're going to have an F as well as an X. Yeah, exactly. Good question.
And what did you say N was again?
And it's just it's generally your sample size. It's how many data points you've got. I think one of the questions on that quiz is how many data points do you have? I think it's the first one. I think it's the first one. Yeah.
Yeah.
Good. Good questions. I like them.
Now,
Yeah, go.
what you're talking about with the frequencies, is that within, like if you have the histogram,
Yes.
Is the frequencies within that one block of the histogram?
The bar, you mean each
Yeah,
bar?
bar.
Yeah, each one of those is an F. So if this bar is 8 tall, and this bar is 12 tall, and this bar is 2 tall, and this bar is 0, you'd add up all those bars to get N.
The bars itself, or what's in the bar?
What's in the bars you don't know exactly. What's in the bars you're calling the middle of the X range at the bottom. So if the bottom of the bar goes from 0 to 9,
Right.
10 to 19, 20 to 29, you pick the middle of each bar. So the first one will be, I guess, 4.5. I'm making up numbers now. 4.5, 14.5, 24.5. You pick, that's what's in the bar at those numbers. The height of the bar is how many of them there are. So if you're in the 1 through or 0 through 9 bar,
Right.
You're in the 0 through 9 bar, and it's 12 high. That means there are 12 4.5s in the data set. The height of the bar tells you how many.
Right.
The distance across here tells you what it is. And if it says 0 through 9, you don't know what, you don't know how many zeros, how many ones, how many twos.
Right.
So you call them all 4.5s. Yeah, you have to.
Gotcha.
Yes.
All right.
And hopefully, and I'm working on that spreadsheet. You guys Carly gave me a great hint last time about how to make that better. I was working on it over the weekend. So, but that's, if you need more, just go back.
So you don't know what's in that bar.
So you assume it's in the middle.
Gotcha.
Yeah, that you have to, because that's the best you can do. You can't do anything else. Do you remember why it was okay to assume that it was in the middle? Jolie's saying, yes, go ahead, be brave.
Because, so it's 0 to 9, the zeros and the 9s will cancel out, and so you'll end up getting 4.5.
Nice! On average.
On average.
The zeros and the 9. So the reason you pick the middle, this is good to just chit-chat about because it happens all the time in the world anyway when you have to deal with data sets. Chances are, well, first of all, there are no 4.5s in the data set, most likely. But the thing is, there probably aren't a bunch of zeros and no 1s through 9s, and there probably aren't a bunch of 9s and no 0s through 8s. Chances are they're somewhat evenly spread through the bar. So the idea that Jolene said is true. The zeros and the 9s undo each other and they revert. It's called regression to the mean, essentially. So, and if you miss it in this bar, chances are you'll catch it on this bar over here. And it worked great for our key data. It worked great for that Excel spreadsheet data. It's going to continue to work fantastic as we go through this course. I mean, you were saying something earlier. Go ahead.
If it's like 0 through 9 and then 9 through, I don't know, 11 or something, do you count, like when they ask you how many, do you count all of them?
Can I answer this 2 ways?
Yes.
Abby's got a question, a very, very good one. Because sometimes you have to deal with data as it's given to you. So the question that Abby has is a good, I think your textbook actually has an example or two of this in the homeworks if you choose to look at those. So what if data is given to you in a histogram, and the first bar goes 0 through 9, the next bar goes 10, 11, the next bar goes 12 through 28, the next bar goes 29 through 52, the next bar is 53, the next... Well, the only thing you can do with that is pick the middle of each one of those bars and use it for the same logic.
Okay, well...
That's one quick answer. A better answer, let me just finish that. The better answer is never do that. If you have the choice to arrange your data in your own way, make it uniformly spaced on that axis down there. Anybody who's taking calculus knows why you do this. If you haven't taken calculus, don't worry about it. Just do that because that way, whenever I see that, I think the people are trying to hide something. Like, I think they're trying to make something look bigger or smaller than it actually is. Like, why would you say 0 through 9 and then just 10 and 11? Unless you're trying to emphasize one of those two things by making the difference. That's my me talking to you as future researchers. Okay? But if you are given data done by somebody like that, just pick the middle, pick the middle, pick the middle. Obvious. Finish that question.
I think
Good.
on the quiz.
Yes. They're uniform.
Yeah.
Yeah.
So it asks
welcome.
like how many are like late. I don't know. How many from 0 to 9? And
Tell you what, let's chit chat at the break. Get
Okay.
this question answered. I like the general, and I'm not because I'm a bastard, maybe I am. But I like the specific, or the general questions, but when it starts getting specific, let's take it at the break happily. If anybody has a quiz question, we can chit chat at our 5-minute break in between. Happily. Vivica, go.
Well, that's what I was gonna say.
Let's chit chat at the break, shall we? Absolutely. When it gets super specific, I try to keep the assessments out of class. But we can, of course, chit-chat when we take our little 5s and 7-minute breaks and stuff like that. Good?
What if they double it, the numbers? Like, what if it's like 1 through 5 and then 5 through 10?
You just pick the middle. I mean, you kind of have to just, well, 1 through 5 and 5 through 10 is close.
Yeah.
1 through 5 is 5 wide and 5 through 10 is 6 wide. But you just have to, everybody catch what I just said? Hopefully that didn't seem too confusing.
Actually, I meant to say 0 through 5. How about
Well, that's
that?
okay. 0 through 5 and then 5 through 10. Oh, doubling up the number on the end.
Right.
This is a good point. So suppose the interval goes 0, 5, 5, 10, 10, 15, 15, 20. It depends on the type of data you have. When you have continuous data, technically speaking, there is no doubling. And here's why. Let's use that as an example. That's a great general question. Suppose you've got this horizontal axis that you're dealing with. And you've got the first bar, let's just do this, throw a couple, use your example, 0, 5, 10, 15, 20. Okay, boom, 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 boom. Just make up some data points. There we go. Blah, blah, blah. Doesn't matter what they are. And suppose this is something like time. So time after something. So you've got a baseline of 0 and then you're counting time after that. So how can this bar go 0 to 5 and this bar go 5 to 10? And the answer is, what kind of data is this?
Continue.
It's continuous. To have something be exactly 5 seconds is just about impossible. It's not going to be exactly 5 seconds. How many numbers are there in time measurements between 0 and 5? Trick question alert, trick question alert. How many time increments are there between 0 and 5? Trick question.
500.
Depends on what time you're talking about. Minutes.
Suppose it's seconds. It's time in seconds. I love that. I'll say Colleen, but it's not Colleen. Damn it. Monica! I'm close to Colleen. Suppose it's seconds.
Right.
Mm-hmm. Give me a data point in this range. 1 second, huh? 1 second? 2 seconds?
4.87.
And that is the point, right? 4.87 pi. 0.5, 0.25, 0.125, 0.06, whatever the hell half of 0.0125 is. How many data points are there between here? Only? Only?
Well, if you're talking about, let's say it's a whole second,
Sure.
60 seconds.
Aren't there subdivisions of seconds? I mean, technically speaking, there's
There-
decimals of seconds. That's
technically,
probably so 4.87. Thank you.
So if we're gonna
How
start.
about 4 point? What's the next biggest from 4.87? Trick question.
4.871.
Isn't it
Oh,
4.87? Oh. Bunch of O's. How many O's? I'm looking for a word nobody's using yet. There's infinitely many data points in here. Technically speaking, anything continuous, any measurement, there's infinitely many. We round them off very often, but there's infinitely many data points. So if there's infinitely many data points here, and infinitely many data points here, what's the chance it lands exactly on 5? 0. It's not going to land exactly on 5, which means 4.9s, 4.87s, 4.92s end up in this bar. 5.01s, 5.1s, 5.09s end up in this bar. So don't worry yourself about continuous
But
data.
when you're dropping those off right at the end, or you cut them off, like you're gonna cut the 5 and 10 off, right?
But they don't even exist technically.
Right.
That's my point, is that you're never going to get, I mean, if you're sitting with a stopwatch and you're timing something and it comes up to exactly 5 seconds, it's not. It can't, because it's too hard to land at the corners. All we're doing is we're putting these up as, they're called bins in Excel, a place to dump the data. It decides what the data gets dumped to, left or right side. So the chances of it landing on 5, on 10, on 15, on 20, when you have infinitely many data points to land on, are nil. So you're just picking those as divisors.
So what you're saying is, like, if the bins went from like 0 to 5,
Mhm.
and then the next bin was 6 to 10 or whatever, you're gonna lose what's
You,
between
if
5
it was
and 6.
continuous data, yes. If it were continuous data, you would lose everything between 5 and 6. But if it was discrete data, then you'd have to do it that, excuse me, then you'd have to do it that way, right? 0 to 5, 6 to 10, or something like that. Because if it's discrete data, and you went 0 to 5, 5 to 10, you'd get confused as to where a 5 actually went. For discrete data, you have to see the gap. For continuous data, you could totally have it just like this. And you should actually have it just like this. Great question. Dan, you're going to see that over and over and over again in here. As we flip-flop back and forth between discrete thinking, which we do all the time. Great questions, great questions. Everybody follow that little line of argument? And you'll see it again and again and again. Discrete data, you're not going to see like this. You're going to see those jumps, 0 to 5, 6 to 10, 11 to 15, whatever it ends up being. Because you have to. Otherwise, you end up double counting data, or you confuse your data collection. But continuous data, you have to have like this. Good general questions. Nick?
What if we had to find the percentage between those two intervals?
Till the break. We'll chit chat about. I can't do squat right now because I didn't give you a scale.
Gotcha.
But by all means, we'll chit chat at the break. Yes. Cool. That's why I think on that primer quiz, the first couple, the first question and the Excel question were percentage-based questions. What percentage are above? What percentage are below? Because I need you to be able to count that kind of stuff. It's not much. It's just counting. But at the same time, I need you to know how to do that stuff because although there's not much math in this course, the math that is there seems to trick people up because you're so busy factoring quadratics anymore for Math 111 that you forget to do things like count. So that's okay. So we're going to take a trip down memory lane today and ask you some more questions. So, I have a question. I'm going to give, oh thanks Nick, just stop it and start it again, thanks.